All right, so today we're going to be talking about parallelograms. This is the start of our quadrilaterals unit. As you can see on the screen, parallelograms actually break off of quadrilaterals. The thing we need to know about what a quadrilateral is that it has four sides. Okay, and if two pairs of those sides are parallel, it's going to be a parallelogram. Okay, and parallelogram is what we're talking about today. Now, if no sides end up being parallel, we have what's called a kite, which we actually won't cover in this class. And then if one side is parallel, we'll have the trapezoids. Breaking off of the parallelograms, you'll have the rectangle and the rhombi, and then the square is like the love child of the rhombi and the rectangles. So let's look at some of the properties of a parallelogram. Okay, so the parallelogram and its sides. Opposite sides are parallel. Okay, so that means side AB is parallel to side CD, and line AC is parallel to line BD. Okay, so that's one of the properties that we just know. Okay, two, the opposite sides are going to be congruent, which means that AB is going to be congruent to CD, and AC is going to be congruent to BD. Okay? Remember, we will have to have these properties memorized. The quicker you get them locked in your brain, the better. So let's look at an example of using these properties. Okay, so if we're looking at example number 1, it's asking us to find A and B. Remember, sides are congruent. So this side is congruent to this one, and this one is congruent to that one. So B will equal 11, and A will equal 9. Example number 2, we actually got to use a little bit of algebra there. Okay, so the two top and bottoms are congruent, and the sides left and right will be congruent. So if we're solving for x, bx plus 2 equals 4. Subtract our 2 to the other side, so x equals 2. And if we're solving for y, y minus 5 equals 12. Add 5 to both sides, and y equals 17. Okay, if you have any questions about the sides, please let me know in class, and we can talk that through. One thing to remember about sides, the only thing you can do with them is set them equal. Okay, we'll talk about the angles in a second, but again, sides, all you can do is set them equal. Now, if we're talking about angles, opposite angles are going to be congruent. Now, this is due to the fact that those sides were parallel. So if we had parallel lines, okay, it actually gives us the opposite angles. So those angles there, and A is congruent to D there. Okay, so that's what it means by opposite angles. And again, that comes from the fact that they are parallel lines. Consecutive angles are going to be supplementary, which also goes back to the fact that they're parallel lines. If I was to extend line BD there, right, and then extend the ends, if we did our X's and O's, notice that we have an X and an O there. We can do the same thing on this side. Okay. Notice that the opposite sides were both congruent, okay? And the consecutive sides, remember consecutive means same side, okay, were supplementary, and supplementary means 180. So if they're congruent, we're going to set them equal. If they're supplementary, we're going to add them and set equal to 180. Okay, remember consecutive again means same side. So let's put this to the test. Example number 3, we're looking for y. Notice that those are opposite angles, and if they're opposite angles, they will be congruent. So we will have y minus 60 equals 56. We'll add 60 to both sides, and y equals 116. Okay, y equals 116. For example number 4, it asks us to find f. Notice that those are consecutive. They're on the same side of our parallelogram, which means we will add them together and set them equal to 180. So we'll have f plus 30 plus 72 equals 180. So f plus 102 equals 180. Subtract the 102, and f equals 78. Okay, so f will equal 78. If they asked for that angle there and not just for f, again, we would plug the 78 back in, okay, in order to find what that angle was. We have to be sure that we're reading our questions thoroughly, because it, again, depends on what they're asking us for. Here, they just asked us for f. If you have any questions on the angles, please let me know in class, and we can talk about those. Remember, sides we can only set equal. Angles we could either set equal or add to 180. The last part of parallelograms is their diagonals. They also have special properties. Again, we have to remember all of the properties, so my suggestion to you is to maybe make some flashcards or maybe a foldable to help you remember the properties. So the diagonals of a parallelogram, they will bisect each other. Remember, the word bisect means to cut in half. So if we're cutting something in half, right, it means both of their parts are equal. Okay? Means both of their parts will be equal, which essentially is the part down there. It says the diagonals will split each other in half. So if I draw my diagonals in here, and I'm going to label the point in the middle, I'm going to label it E. Okay, so what actually ends up happening is AE is going to be congruent to ED, and CE is congruent to EB. Okay, ED is not congruent to CE. That's going to be a property of a different quadrilateral, but for parallelograms, the diagonals will bisect each other. Okay, so let's look at some examples. All right, so let's look at an example here of the diagonals. All right, so it asks us to find the value of m and n. Remember, the diagonals bisect each other, so this diagonal is congruent to that one, and this one will be congruent to that one. Let's start with the red there with the 2n because we're not going to have m on either side of the equal sign, so that's going to be the easier one to find. So we'll have 9 equals 2n minus 1. We'll add 1 to the other side, and we'll get 10 equals 2n. Divide by 2, and n will equal 5. Now, if we are looking at the one in blue there, okay, we're going to have 3, oops, we're going to have 3m equals m plus 8. Remember, we want all of our variables on one side and our numbers on the other, so we're going to subtract m to the other side. So we'll have 2m equals 8, divide by 2. So we get m to have a value of 4. Okay? So diagonals are kind of like sides. All you can really do with them is set them equal. Okay, so diagonals and sides will set equal for parallelograms. Angles, depending on if they're opposite, you'll set them equal, and if they are consecutive, you'll set them equal to 180. We're going to look at just a few examples of what this may look like when we see it on an SOL or on our tests. So here they tell us pieces of information about the parallelogram to the right. It says if AD is 20, so AD is this piece here, so they're telling us that one is 20, please find BC. I would like you to please pause the video here and see if you can figure out what CB will be, and I'll actually list the property underneath when I solve it for you. All right, so here the value should have been 20 because opposite sides are congruent. Okay, the next question says if DB, so this full length here, whoops, this full length there is 22. What is the value of DE? Again, please pause the video here and see if you can figure it out on your own. All right, so the value of DE would have been 11 because diagonals bisect each other. So if the full length was 22, we would divide that by 2 to get 11. All right, so again, using the picture on the right, they tell us that the measure of angle 1 is 30. I'm going to fill that in. Okay, and they want to know the measure of angle 4. So please pause the video here and see if you can figure it out. Okay, so here the answer was 30. Opposite angles are congruent. So that means that whole angle, actually 1 plus 2 and 3 plus 4 would be equal. Okay, the reason we know that 4 is indeed 30 is because of alternate interior angles. For the next question, they have the measure of angle ADC. So I'm going to trace ADC. Here's ADC. Okay, is 115 degrees. Then they want to know what is the measure of angle ABC. So here's ABC is this angle here. So please see if you can figure out what that value will be. Okay, so this value here would have also been 115 degrees because, again, opposite angles are congruent. Okay. If the measure of ADC is 130 degrees, and the measure of angle 1 is 35, then what is the measure of angle 2? Now, I want you to pause and see if you can figure it out, but I will walk you step by step through this one in just a few seconds. All right, so hopefully you have tried on your own. If we look at those two angles as a whole, so ADC and this angle here, those are going to be consecutive angles, which means they should add up to 180 degrees. So I have 130 plus x plus 35 equals 180 degrees. Okay, combine your like terms first. So we'll get 165 plus x equals 180. Subtract the 165. So x will equal 15 degrees. Okay, so there the measure of angle 2 would have been 15. So we can double check ourselves. If we add 15 to 35, we'll get 50, and 50 plus 130 does indeed give us 180. If AB is 3x plus 1 and DC is 19, then please solve for x. So if I highlight AB, which is the bottom one down here, that's going to be 3x plus 1. And DC, which is the top line up here, is 19. So please find the value of x. So here, our value for our x would have been 6. If you need the work, it is over to the right. If you are struggling with any of this, we will be discussing it in class. I'd like you to try the last two examples there on your own, and we'll discuss those in class tomorrow when I see you.